Hey guys, welcome to another video. Today, another nice question in the Extension 1 syllabus this time. This question comes from the Penrith 2023 trial paper. It's the last question in the paper. It's in the topic of trig and polys. Now, this type of question is getting more and more common. Traditionally, it's an Extension 2 question, and it still can be an Extension 2 question, but once they sort of remove some parts, it makes it Extension 1 compliant. So let me show you to you 9 marks. It's a lot of marks in the Extension 1 test. So it's a great question. So now, before I begin, as always, if you haven't already done so, please subscribe to the channel, tell your friends, and like the video. All right, guys, let's dive right into the question. So, all right. So this question looks quite simple. So let's have a read and see how we go. So prove the identity. Sorry, give me 1 second. Okay. Prove the identity. Okay, I'll use green. Okay, that doesn't look too bad. Now, the issue there is with this sort of 3 theta, right? I think with 3-unit technique. So if you were doing 4-unit, you can use complex numbers, right? If you're doing 3-unit for this one, I'll probably need to use compound, right, to expand 3. Okay, and then find the question. Okay, division of polynomials, interesting, right? And then from part 1 and okay, the question says let that happen. Okay, find the roots, so solve the equation basically to that, and then find exactly. Okay, cool. All right, let's do this. So part 1 is compound angles, right? And it might be a little bit messy, but let's see. So that equals to 10. Let me zoom in a bit more. Looks like it's 10 2 theta plus theta. Now we know with compound 10a plus b, that's like 10a 10b all over 1 minus 10a 10b. And I'm thinking maybe just further expanding that and that, right, into using double angles. So double angles is 2 tan theta all over 1 minus 10 squared plus 10 theta all over 1 minus, now a bit messy here, 2 10 theta all over 1 minus 10 squared multiplied by 10 theta. And then it just feels like common denominators, right? Just common denominator that, and let's see where that takes me, right? So big fraction first, right? And then common denominator, small fraction here, minus 10 squared. And on top 210 plus 10 plus 1 minus 10 squared. Yeah, something like that. And then denominator 1 minus 10 squared as well. And now let's see. So this term here gets to 1 minus 10 squared and minus 210 times 10, so 210 squared. Yep, is that okay? Right. So all I've done there was basically just common denominated both the blue highlights there. Yep. And then just a little bit of cancellation here. You guys okay with this, right? Yeah, if it's on the numerator and denominator, cancel out. And let's just see if I can collect like terms and get what I want. Let's have a look. So what's left? On top there's 210 plus 10, that's 310. And minus 10 cubed, it looks like. And on the bottom it's 1 minus 310 squared. Now, is that what I want? Let's have a look. 310 minus 10 cubed. Perfect. Done. Yeah. Tick. I mean, theoretically, I should have did, it's not too late for me. Should have done the left-hand side, right-hand side, just to be amazing, all right, when I go and prove identities. So I go left-hand side, and equals right-hand side. Perfect. Yep. Done. So part That was 3 marks, man. There's a lot of marks. Now, part 2, division of polynomials. For those that haven't seen the synthetic method, right? I put up a video a while ago now on synthetic for division of polynomials. It's super quick, right? For this question, I'll do it the old school division of polynomials way, and then off to the side, maybe I'll show you the synthetic. Now, can you use synthetic at school? Not sure. Ask your teacher. No. So if they're comfortable for you to use a method to get the answer, synthetic method for this is amazing, right? So let's see. Let's do old school first, right? So x plus 1, and what's the polynomial that we want me to do? Okay, cube minus. Okay. X cubed minus plus 1. Okay, let's divide. So the term multiplying to x, get rid of this, is x squared. Once you write down x squared, multiply that down, so x cubed there plus x squared. Subtract. So when you subtract, this guy goes away, minus, and then minus becomes a minus, so that's minus 4 x squared. Yeah, bring down this term, becomes minus 3x, so then minus 4x is the next term in the quotient. Then multiply it down, minus 4x squared, minus 4x. Once again, subtract. That goes away. That minus that becomes a plus. That's x plus 1, so, which is nice because there's no remainder, right? Yeah, so that's a factor. So therefore, now how do they want me to find the quotient? That's the quotient, right? The quotient's just upstairs. So that's all they want, right? The quotient's just the answer. So therefore, quotient equals to x squared minus 4x plus 1. Now, off to the side, man. Let me show you the synthetic method for those that are keen, right? And it's just cool, right? It's just a really cool way of doing division of polynomials. So synthetic method is really straightforward and it's super quick, right? So you basically draw yourself this, right? Because this is my original polynomial, right? This polynomial here, right? I'm going to write the coefficients of this polynomial, 1, -3, -3, 1 here. Now, because I'm dividing by x plus 1, I want you to write -1 over here, right? The opposite, right? So if it's x plus 1, right, it's like the root of that x plus 1 over there. And then the concept is really easy. Add times, add times, add times, right? So check this out. So you start off with 0 here, and then you add, right? So add vertically, right? So add becomes 1, times, so times here comes -1. Then you add again, -3 plus -1 is -4. And you times that with -1 again to get 4. Then you add again, -3 plus 4 is 1. Times that with -1 to get -1. Add that to get 0. Once you get that, your answer is always, right? Is always the remainder, right? Is over here. And then the coefficients of the answer of the quotient is over here, right? So from this, I can basically say that the quotient is x squared minus 4x plus 1. No remainder. Bam. Right? Done so quickly. Yeah. Especially, saves a lot of time when you're dividing x plus 1 into like power 5, right? Now, synthetic method only works when the divisor is linear, right? So x plus 1. So it doesn't really work when it's x squared plus 1, right, etc. But when it's x plus 1 or x plus 3 or x minus 3, works amazingly. Guys, either way, we got our quotient now. 5 marks out of the 9 marks done. The last part is basically where in 4-unit maths, right, this question is like quite common, right? It's quite common. It's not, so it's getting more and more common in 3-unit. I've seen it a few times now, right? So let's have a look at what we have to do. It goes, using the identity, letting x be this, right? Letting x be tan theta, find the root of this. Now, what I want you to do for part 3, yeah, write down write down part A for me, right? Where it's like tan 3 theta equals to, what was it? Tan 3 theta, 3 tan minus cubed. So 3 tan minus 10 cubed. And then I think it's like 1 minus 3 10 squared. Let me just check that. Yep. Okay. Now, so whenever I do this, I always ask my students so they tell you to let x equal to tan theta, right? So they're going to replace each one of these tan thetas here, each one of these, right? They get replaced with, so let x equal to tan theta. Now, in this question, it's actually a double sub, right? On the right-hand side, so on this side here, we let x equal to tan theta. And then on this side here, I'm going to be smart. I'm going to strategically let the pink part be something else. Now, what do I want to do? Because if you think about it, if I let this be x, right? If I let tan be x, that becomes 3x minus x cubed all over 1 minus x squared, right? I gotta be really smart about this and let this here be something such that I create my quadratic equation, right? This is the my cubic equation. I want to create something that looks like that, right? X cubed minus x squared minus x plus 1. So I have to let this side here be something to make that happen. So for example, right, I'll tell you what the answer is. If I let this be 1, right? If I let this side be 1, look what you get. You get times this up, you get 1 minus x squared equals to 3x minus x cubed. Bring every term over to this side, then you get x cubed minus, oh, sorry, that's a 3 there, right? Yeah. Minus 3x squared minus 3x plus 1 equals 0. And that looks exactly the same as a cubic, right, that they wanted me to prove. So what am I trying to say? The hard bit here is basically going, okay, I'll let the blue part here be x. Okay, fine, I get that. I get this fraction. What do I let this side be to get the same expression as the one that I want me to prove? Now, sometimes they change it around. Now, in 3-unit maths, generally speaking, they make it quite easy. In 4-unit, it can be quite hard, right? In 3-unit, it's generally 1. Now, why is that important? So then when I let this substitution happen, I go, let tan 3 theta equal to 1. Yeah, and then using my all stations central, right? I go, okay, if tan 3 theta is 1, then 3 theta equals 2. Now I know it's pi on 4, right? And in ASTC, tan is positive in the first and the third, right? So it's theta and 180 plus theta. So pi on 4, pi plus that is what? 5 pi on 4. And guys, I say this in my class all the time. When it's 3 theta, I need 3 answers, right? I've got 2 from ASTC, and then I add 360, right, to this one here, right? I add 360 to get another answer. So add 2 pi to that. So add 2 pi. And I get, what's that, 7? No, 9 pi on 4. Okay, so get your 3 answers, right? Yeah, I only need 3. I don't need any more. Because once you get that, I'm going to move everything down a bit, right? Just so I can have a bit of space to do this pink part. Yep. Now, once you get those 3, divide to make theta the subject, divide everything by 3, right? And I get pi on 12, 5 pi on 12, and I get 9 pi on 12, which is 3 pi on 4, right? So my final theta answers. So yeah, 5 pi on 12 and 3 pi on 4. Perfect. Now, once you find theta, right? Once you find the values of theta and you've let x equal to tan theta, if you think about it, right, you've actually solved this question, because if theta's your answers, right, and you've got x equal to tan theta and x cubed, that's your equation, therefore, x equals to tan theta, right? And you found all the thetas. So what you're supposed to do is take these 3 thetas here and you pop them into theta, and that's your answer. Tan pi on 12, tan 5 pi on 12, tan 3 pi on 4, that's your answer. Yeah, they're your 3 answers. So therefore, x equals to tan pi on 12, tan 5 pi on 12, tan 3 pi on 4. Perfect. Right, they're my solutions to this. Now, let me look at the question. What are they asking me to do, by the way? Find the roots. Done. And then hence find the exact value of tan pi on 12, right? Okay, cool. So I've got that now. And if you were amazing, you would have noticed that this guy here is an exact value, right? Yeah. You will notice it's an exact value because that's like negative tan pi on 4, right? Because it's tan pi on 4 in the second quadrant, which is -1. All right, cool. Now, the question basically now wants me to find exact value of these ones, right? Exact value of that. Now, what I'm going to do is go, okay, let's zoom out. Let's take a step back. Why did they make me do that division of polynomial in part 2, right? Look at this. They made me do the division of polynomial in part 2 because, right, and I'll do a green pen here, because that, whatever answer that is, helps me factorize this. Because if I wanted to solve that green box, right? Yeah, I now know that from my division of polynomials, right? If I sort of come over here, right? I know that, and I'll zoom in now, that the polynomial x cubed minus 3x squared minus 3x plus 1, right? That was the original polynomial. That factorizes to x plus 1 and x squared minus 4x plus 1, right? Yeah. So I'm going to use this factorized form to replace the green, and you'll see something quite cool, right? You'll see where I'm going with this. Yeah. Hopefully. Right? You go replace that now with x plus 1, x squared minus 4x plus 1 equals 0. Now, why is that important? Because I know from this, right? From this, I get two solutions, right? Or two sets of solutions. This one here, x would equal to -1. The solutions for this, right, are basically the same solutions as these two, right? It's a quadratic. Whatever answers there are, they should be equal to this. And that's how I sort of find the exact value of tan pi on 12. I solve this using the quadratic formula and then try to go, okay, one of them is tan pi on 12, the other one's tan 5 pi on 12. So your next aim here is to solve this using, you know what, I'm going to solve this using completing the square for those that know how to do it because it's just faster. Yeah, add 4 to both sides. Yeah, that becomes a perfect square of x minus 2 squared equals to 3. And then x equals to plus minus root 3 plus 2. Now, once you're down there, guys, say to yourself, okay, one's plus, one's minus. Which one? I don't know that that one's plus, one's minus. One of them is tan pi on 12. The other one is 5 pi on 12. How do you know which one's which? Tan pi on 12 is smaller, right? And also tan 5. No, yep, they're both positive. Tan pi on 12 is smaller, right? Because the tan graph sort of is increasing, right? As you get higher, as a next value, the angle gets bigger, right? So I know that, therefore, since tan pi on 12 is smaller, it's less than, right? Yeah, then tan 5 pi on 12, therefore, tan pi on 12 must be the negative version, right? Must be the minus root 3 plus 2. Yeah, and that's my answer, guys. What a question. Yeah, it's very 4-unit. Even in 4-unit, right? I reckon it's a bit challenging, right? As a concept, but the fact that they're now starting to shift this into 3, nothing here is 4-unit, right? We haven't used any 4-unit techniques, so that's why in 3-unit they can ask it, right? It's just hard. So let's recap. To do this question, we need to do compound angles and then some double angles and some algebra, right? To prove part 1. Part 2, division of polynomials, piece of cake, especially if you have the synthetic method. Step 3 now. Step 3, part 3, we had to replace tan thetas with x and then be really strategic about letting this side be 1. How do I know it's 1? Because if I let it be 1, it creates algebraically the question that they want me to prove, right? Solve. Yeah. And then once you let it be 1, you get the 3 answers for theta, which you'll sub into tan. And there are your 3 answers. Tan all 3 of those angles. And then to find the exact value of tan pi on 12, I basically I used in this case the division of polynomial, right? I know that the tan 3 pi on 4 was -1, which is this side here. So I disregard that, right? That side, that one there's gone. And I know that the quadratic answers are going to be the two angles, right? Of tan pi on 12 and tan 5 pi on 12. Once I figure out that tan pi on 12 is smaller, it's the negative case. Guys, what a nice question. Hopefully that was nice for you as well. Guys, like the video, subscribe to the channel, tell your friends. Thank you very much. See you later.